So really quick, I want to talk about equivalent exponential expressions. What that means is how we can take an exponential expression and then create an equivalent version to it. Meaning if there's, how can I make an equal expression? So here I have 16 squared times 4 squared. So what I'm going to do is I'm going to look at this one over here. So I have 16 squared times 4 squared. If they have the same exponent, what I can do is actually put them in the same set of parentheses with the same exponent up top. So that's the same as saying 16 times 4 all squared. 16 times 4 is 64, and then I can write that as 64 squared. So what I'm doing is essentially taking this whole thing up here and multiplying it but keeping the same exponent. That's one option. The second option I have is over here. So I know 16 is actually 4 squared, 4 times 4. So what I can do is replace the 16 with 4 squared, but then I have to keep that 2 as the exponent. So now, which is great, is I have the same base number here, 4 and 4. So if I have 4 squared squared, so 2 times 2, that's the power rule. We have 4 to the 4th. 4 to the 4th times the original 4 squared. I can add these two, and I get 4 to the 6th. So this one, 64 squared, 4 to the 6th, and my original are actually all the same answer if I were to blow it up and get the answer. There's actually one more way to do it, and that's if, okay, can I break down 16 and 4 even more? So I know 4 is 2 squared. So I'm going to put a 2 squared raised to the 2nd power over there. And 16 is actually 2 to the 4th power. So I can write that as 2 to the 4th squared. So this is another way to do it because now I can have the same base and I have all these power rules. So 4 times 2 is 8, so I have 2 to the 8th times 2 times 2 is 4, which is 2 to the 4th. So then I can add these two up and get 2 to the 12th. So all three of these, 2 to the 12th, 4 to the 6th, and 64 squared, are all equivalent to this option right up here.